Hello everyone. This is notes for 34A, and so you're going to click into Math 8 and you're going to go into notes for 34A, and then right here, this is Mr. Daniel's screencast. He's going to take this out and put in this screencast. So remember that the screencast is always in the introduction. And then we go to question 1. So this lesson is all about taking information that's given to you and drawing the graph. So it says the cost for meat is $12 per pound at a store. Graph the relationship between the number of pounds of meat and the total cost. Okay, so if we buy 0 pounds, it's going to cost us $0. So we start with a dot at 0. And then it's going to cost $12 if we buy 1 pound. So we're going to go up to $12, 1 pound, and there is our graph. Remember that this is called a proportional relationship because it starts at 0, 0. And then we submit our question and we go to number 2. Number 2, Jake started a marble collection with 10 marbles. He adds 5 a week to his collection. Create a graph showing number of marbles collected over time. So we go back, and if we start and we read, it says Jake started a marble collection with 10 marbles. So that's how many marbles that we started with. That's where we have to start the graph. Then it says he adds 5 a week to his collection. So we're going to start with 10 marbles, and then we're going to go up 5 over 1. So we're adding 5 marbles a week, and then we submit. Number 3. Janet got a $45 coffee card from work. She spends $5 a day on coffee. Create a graph showing the remaining balance on her card over time. Okay, so if we look at the question, the card that she got had $45 on it. So that is our starting amount. We're going to start our graph at 45. Okay, then it says she spends $5 a day on coffee. Now, she's spending that money. So the amount on the card is going to go down $5 a day. So we're going to start our graph at 45 because that's how much money is on the card. Then we're going to go down $5 and we're going to go over 1 day, and then we're going to submit. Number 4. Number 4 says, regarding the initial value of the graph shown above. So we have a graph right here, and then it says at how many seconds the force is how much. So ladies and gentlemen, when you see the words initial value right here at the bottom, that tells you that we want to start at 0 seconds. So always, this number is going to be 0. At 0 seconds, the force is what? So I go to 0 seconds on the axis, and I go up, and the force is 15. So I type in 15. So every time that you see the words initial value, that means that they want you to go to 0 and then go up or down until you hit your line. So at 0 seconds, the force is 15. Submit. Number 5. So we again have a graph regarding the initial value. Again, see how we have initial value again? So we have to start with the starting amount. But now it says, and the rate of change. So now we have to do both of them. So at how many seconds the force is what? Okay, remember that we always want to start at 0 seconds. So we're going to go to 0 seconds. We're going to go up till we hit the line, and it looks like the force is 5. So we're going to type 5. At 0 seconds, the force is 5. Okay, now we need the rate of change. Now, in order to get the rate of change, we need to make our slope triangle. And it looks like we don't have the polygon tool. So I'm going to go ahead and draw on our picture. So I have a perfect point here, and I have another perfect point here. So this is my triangle. Now, you have to be careful because if you look right here on this side, do you notice they're going by 5s? So if we count, it's 1, 2, 3, 4 spaces. But we have to count by 5. So it's 5, 10, 15, 20. So we went up 20 and then over 1. Notice on this axis it's going by ones. So our slope is up 20 over 1, and 20 divided by 1 is just 20. So our rate of change is 20. At 0 seconds, the force is 5. The rate of change is 20. Submit. Number 6. Same question. So we go to our graph regarding the initial value and the rate of change. So we're going to do both of them again. When we're at 0 seconds, remember we're always at 0 seconds. Now look at the graph right here. Do you notice that when we're at 0 seconds, we're at 0 miles? So we're going to put 0 in here. Ladies and gentlemen, this means that this is proportional. Anytime that the graph starts at 0, 0, we have a proportional relationship. Okay, now we need the rate of change. Remember, we needed the initial value and the rate of change. So let me make my slope triangle. So I have a perfect point here. I have a perfect point here. Now, I only went up 1 space, but if you look, aren't we going by 80s? So 1 space is 80. So I went up 80 and I went over 1. So my slope is 80 over 1, which is 80. So now I'm going to go type in 80 miles per second. And then I submit. Uh-oh. Oh, I didn't see this down here. Is this situation an example of a proportional relationship? We just talked about that. Yes, it is. And we submit. Remember, it's proportional because it starts at 0, 0. Then we go to number 7. Okay, number 7, it says identify the numeric values of the rate of change and the initial value. So the same thing. We have to do the same thing. So let's start at the initial value because that's where we've been starting. So if I look at the graph, it looks like the initial value here is 2. Where the red line hits the y-axis is at 2. Okay, now I need my rate of change. Okay, to get my rate of change, I'm going to make my slope triangle. So I have a perfect point here, and I have another perfect point here. Now, when you look at the axis this time, notice we're going by ones, and we're going by ones. So if we're just going by ones, I just count. I went up 4 and over 1. So my slope, my rate of change, is up 4 over 1, and 4 divided by 1 is 4. So now I go back here and I put 4. And then I make sure there's nothing else and I submit. Number 8. The graph shows a linear relationship of the water level in a tank and time. Okay, now do you notice that the x-axis here says time in hours and it says t, not x? And then over here it says the water level in feet and it says W, not Y. So this tripped me up a little bit because I always just do Y equals, but now we have to put in W instead of Y and T instead of X. Okay, so we're starting out exactly the same. It says find the initial value and then find the rate of change, but then we're going to add now and we're going to write the equation. So our initial value, okay, if you look at your y-axis, do you notice we're going by 4s? And this looks like it's up about maybe at 25. So we're going to say that at 0 hours, the water level is 25 feet. Now, if you estimate where it is and you get the answer wrong, then just go back and estimate again, okay? Now we need the rate of change, so I need to make my slope triangle. So I see that I have a perfect point here, and I have a perfect point here. Now, when I look at my triangle, I'm going down, so my slope is negative, and then it's only one space, but it's not going by ones. Do you see how it's going by fours? So I went down 4. Okay, now, if I look at this axis, okay, do you notice that I went over 1, 2, 3, 4 spaces, but now look at the bottom. If I go over 4 spaces, do you see how that's actually 1? So I went down 4 over 1. See how on this axis, 4 spaces is 1. So my slope is down 4 over 1. Negative 4 over 1 is negative 4. So now I type in negative 4 feet per hour. So it's going down 4 feet every hour. And then the equation, so remember how our equation is y equals mx plus b. But if we look at the y-axis, see how it's w? So we're going to do w equals, and then our slope was negative 4. And then if we look at the x-axis, see how it's t, not x, t. And then plus, and then our y-intercept, which is our initial value, which is 25. So w equals negative 4t plus 25. And then we submit. Number 9. Identify the rate of change in dollars per hour and initial value for the linear situation modeled below. Okay. So we have to look at our table, okay? And remember that your input, that's your X, that's your hours, and then your money is your Y, that's your output. So remember that the slope is the change in the Y over the change in the X. That's the rate of change. So if we look at the money goes from 2 to 12, so it goes up 10. And then the hours go from 0 to 4, so it goes up 4. So our slope, our M, is up 10 over 4. And then we can reduce that by dividing by 2, so it's up 5 over 2. So that is our slope. Okay? So now we go and we type in 5 over 2. Now, right here, see how it says select an answer? 5 over 2 what? Well, if we look at our Y values, see how it's money, dollars, and then the X's are hours, so it's dollars per hour, because it's always Y over X. Okay, then we need the initial value. Remember that the initial value is always at 0. Now, 0 what? It's always where the X is 0. So if we look at the hours, okay, see how when the hours is 0, so this is going to be hours. The cost is how much money? Well, at 0 hours, isn't the cost $2? So $2. Okay, now we write the equation. And do you notice again that we're not using X and Y? We're using H and M. So M equals, okay, our slope, our rate of change was 5 over 2 H plus our initial value of 2. So our Y value is the M and our X value is the H. And we submit. Number 10. Identify the rate of change and the initial value. So this is the same question. Then we're going to write the equation. So the first thing that we do is we get our rate of change. So remember, oh, and here they gave us, this is X and this is Y. So the Y's, 6 from 6 to 12 is up 6. 1 to 2 is up 1. So the Y's go up 6. and the x's go over 1. So our slope, our rate of change, is 6 divided by 1, which is 6. Okay? So now we're going to type in rate of change is 6. Now 6 what? $6 per ride. The y value is the dollars. Y goes on top. Dollars per ride. Okay, now we need the initial value at 0 rides, because x is the rides. The cost is what? Well, if we don't ride any rides, isn't the cost going to be 0? At 0 rides, the cost is $0. Okay? Now, how did I know that? How did I know that I was right? Well, if I make my table, my x and my y, and I go 0, 1, 2, I know that at 1 it's 6 and at 2 it's 12. I know that I'm adding 6 every time to go forward. So if I need to go backwards to get 0, I have to subtract 6. So I have to do the opposite of going forward. So 6 minus 6 is 0. And remember, that means this is proportional. A proportional relationship is when the y-intercept is at 0, 0. Okay? So now we're going to type the equation, and this time we're using x and y. So we have y equals m, which is 6x, plus b, which is 0, plus 0. Now, wait a second. 6x plus 0, if I add 0 to anything, it just stays the same. So I could just type 6x. Y equals 6x, because 6x is the same as 6x plus 0. Submit. Number 11. Amy is always losing her tennis balls. At the beginning of tennis season, she has 28 tennis balls. Okay, this is important. At the beginning of tennis season, she has 28 tennis balls, and she loses 3 tennis balls a week. Okay, model the equation above with a graph, and then we want to find the rate of change and the initial value and the equation. Okay, so how many tennis balls does she have at the beginning? She has 28. And then how many is she losing? She's losing 3 balls every week. Okay, so we're going to start with 28 tennis balls. So we're going to put a dot at 28. Then we're going to go down 3 tennis balls and over 1 week. Okay, so what is our rate of change? Well, isn't that we're losing 3 tennis balls? So -3. What is our initial value? Well, didn't we start with 28 tennis balls? So 28 is our initial value. Okay, now we have to type y equals mx plus b. Okay, which one is the m? Is it the -3 or the 28? The m is the -3 because that's the rate of change. So y equals -3x, and then the initial value is the b plus 28. And we submit. And the last one, number 12. Rebecca is saving money for college expenses. She's saving $150 per week from her summer job, and currently she has $50 a week saved. Okay, we always have to start with how much she has now. So how much does she have now? She has $50 now. So we have to put a dot at 50. Now, lost the problem there. How much is she saving every week? She's saving $150. Okay? So we have to start at 50, and then we have to go up 150. So we've got to count by 50s. 50, 100, 150, and then over 1 week. Okay, now, our rate of change is how much she's saving. She's saving $150 per week. So 150 is our rate of change. Now, the initial value is how much money she has at the beginning. Didn't she have $50 saved? So the initial value is 50. And then finally, we're going to write the equation. Y equals m is our rate of change, 150, x, plus b is our initial value, 50. Y equals 150x plus 50. Submit. And you are done with the notes, and now you're ready to go on and do the homework for number 34. Have an awesome day, and I will see you next class.